listening to B2B Tech Talk with Ingram Micro, the place to learn about new technology and technological advances before they become mainstream. This podcast is sponsored by Ingram Micro's Imagine Next. It's not about the destination. It's about going someplace you never thought possible. Go to imaginenext.ingrammicro.com to find out more. Let's get into it.
Welcome to B2B Tech Talk with Ingram Micro. I'm your host, Shelby Skurhawk. And our guests today are Jeff Shao, Director of Ethernet Alliances, and Bill Webb, Director of Ethernet Switching for the Americas, both of NVIDIA. Jeff and Bill, so thrilled to have you here today.
Thank you, Shelby.
Yeah, great. Thanks, Shelby, for having us today.
Well, so today we are talking about trends in enterprise data centers. But first, Jeff, NVIDIA is well known for its GPU solutions in gaming, but NVIDIA is also a leader in kind of end-to-end open networking, really for all layers of hardware and software. So tell us what that means then for enterprise data centers.
Sure, Shelby. I think you're right. NVIDIA is well known for its GPUs, not only for gaming and computer graphics, but also in artificial intelligence, machine learning, and high-performance computing. So in fact, NVIDIA GPUs provide accelerated computing in thousands of applications that reshape all industries. For example, NVIDIA GPUs are used in recommender systems, voice recognition, patient diagnostics, new drug discovery, manufacturing and industrial automation, automotive drive, 5G, the list goes on. So NVIDIA provides not just powerful GPUs, but also a full stack of technologies and solutions centered on AI, including chips, systems, algorithms, and applications. So when I say full stack, it also includes an open ecosystem where NVIDIA's and partner solutions work together seamlessly in both hardware and software. So before we dive into NVIDIA data center solutions, let's first look at what's happening in the data center infrastructure. Mm-hmm. So as we all know, there are three pillars: compute, storage, and networking in the data center, which constantly outpacing each other. Over years, computing processors get more powerful. Each new generations of processors significantly increase performance every 18 months to 2 years. For example, the latest NVIDIA A100 GPU-based systems can deliver petaflops in performance. And storage devices become drastically faster in both IOPS and latency, leveraging the new mediums such as NVMe Flash. Consequently, the network connecting these compute and storage devices speeds up in a much accelerated pace, from 10 gig to 25, 100 gig, and we have people starting using 200 and 400 gig. So with all these technological advances, building a data center actually takes a lot of heavy lifting, choosing the right architecture, components, deliver and operate, deploy and operate them in the most efficient way. So it's not only just about technologies in compute, storage, networking, virtualization, and security, but also about fast deployment, time to market, operation efficiency, and scalability. Speaking of scalability, so that 90% of the world data is generated in the last 2 years, and much of that is stored in data centers. And new applications today are composed in containers, thousands, millions, or even more of them, dynamically added, run, and deleted in the data centers. And for AI machine learning, the largest models today have over 100 billions of parameters. So there are a lot of factors and considerations in building a data center today. Interoperability between old and new devices, and multi-site hybrid cloud integration, security, consumption, and services models, and so on. So all this means, especially for enterprise customers, that complete end-to-end data center solutions are very critical and indispensable. NVIDIA provides such solutions, proven in the field and for the future, so that enterprise customers can build their data centers faster and run them much more efficiently. So, and also as data centers are in continuous change and scaling, with NVIDIA solutions, enterprise customers will no longer face the challenge of complexity of scaling.
Well, so efficiency and scalability, all of these are issues that that are facing companies, and something that is especially prevalent right now is digital transformation. It's really impacted every business. business operations, back-end IT infrastructure, really everything. So, of course, this trend has accelerated in the last decade with so many emerging technologies. But Bill, what specifically is driving changes in the data center?
Yeah, that's a great question, and I'll kind of discuss it from a bottom-up approach, tying into exactly kind of the transformation to describe that's happening. The ability to scale out and also to kind of maximize their infrastructure is key. As Jeff kind of described, right? Applications need to support more users. We need to get more throughput out of our infrastructure. In the AI world, models are getting larger. There's more and more data, right? So the concept of scale out has really taken over the data center, where we can add infrastructure and these applications and storage can still run at the level of performance required as we scale it out. So how do we build out this scale out infrastructure? It's really focused on, pools of resources of disaggregated infrastructure. So we can, break apart the CPU and storage, the compute nodes and storage. We can also, have pools of GPUs for AI and high performance computing and such. And as applications need these resources, they're dynamically allocated to them and made, accessible to them, kind of on demand. Another aspect of this is how, the technology around how you build and deploy your applications. It's all about leveraging, a cloud native mindset. This is, leveraging virtualization and containerization of applications. This is kind of required really to make the most out of scale out infrastructure with your application. And really, it all leads down to a software-defined data center, the ability to manage and orchestrate this entire system, actually the entire stack, bottom to top and also end to end. So you kind of look at what NVIDIA is, really focused on with our solutions. We want to provide infrastructure that's can support all different workloads on the same infrastructure, right? We want to provide a full stack solution. This includes these kind of components, the hardware components to the software stack that sits on top of it. And we also want to be able to support this, kind of in a multi-cloud environment. So let's say that you start a project, you can, initially run it on a cloud, and a cloud provider is kind of, a bootstrap. And then when you go to production, you can make the decision, a financial decision. Do you continue to run it on public cloud? Do you need your own on-prem resources? And it's a decision that you can make on an ongoing basis. So this is, some of the factors that are really, leading to this, this transformation. Specifically on the network, this is something that is really, I kind of come from the network background. In the data center, this is really changing the game. There's a lot more server-to-server communication in the data center. This is really pushing the performance requirements of the network in the data center. The network has to tie into this software-defined environment. That's critical. And also security is becoming a bigger concern. We'll get to that a little bit later. But now, because you have many different users, potentially many different organizations using the same data center, security now is a critical concern that has to be considered.
Well, so then in NVIDIA's view, Jeff, what are some of the key trends in today's data centers? I mean, I know that's a large question, but in terms of, what is new, what is emerging, and I guess what's essential?
Right. So, I think Bill kept it pretty well. So I think, at the very high level, I would say cloud and AI and the convergence of these two. So we may call this AI-driven cloud. So if we look back, right, so every era of IT solution evolutions is triggered by paradigm shift and culture shift, which come in with disruptive applications and computing models. And the PC and internet era in the 1980s and 90s were with applications such as personal emails, web browsing, and computerized workspace. A mobile cloud era in the first decade of this century was ignited by mobile phones, e-commerce, Google or web searching, and social media platforms that are made available to billions of mobile users. So back then, data centers with thousands of servers were built. And very soon, that size increased to tens of thousands and hundreds of thousands of servers. And then public clouds like AWS emerged. And so with the digital transformation in the last decades, cloud has become mainstream with more and more enterprises embracing it and build cloud on premises. And so this started with public cloud service providers, but now we see legacy telco data centers are being replaced by telco clouds, and legacy enterprise data centers are being replaced by private and or hybrid cloud deployments. So we are seeing the convergence to cloud. So on the other side, today we have a vast volume of data at our disposal. Much of the data is collected by machine, such as in 5G or Internet of Things. So oftentimes these data are unstructured, and without us fully understanding the semantics of the data or how to use them at the point of collection. So all these data can only be processed and analyzed autonomously by machines, so we can keep ourselves on top and extract insights to make sound and accurate business decisions. So often the value of the data must be extracted from its entirety. So models are built and trained in the central data center and inferences made at the edge. So that leads to a new wave of computing where software can learn and machine can reason. So today we are in the era of AI, including machine learning and deep learning. So data center has become the new unit of computing, as we call it. So as enterprise customers embracing this new era, so their networking infrastructure must be changed because of many challenges. For example, applications are virtualized and containerized, distributed across data centers and decoupled from the underlying infrastructure. So that results in a massive increase in the east-west traffic and the need for dynamic provisioning and management of the infrastructure. So if we look at the network fabric, so we see clusters of faster servers drive ever-increased bandwidth, which requires higher hardware efficiency from the switches. So when servers moved to 25 gig, switch interconnects were at 100 gig. And as servers now running at 100 gig and higher speeds, the switch interconnects will move to 400 gig. And then manual network configuration built for tens of nodes, that doesn't scale to meet the needs of cloud computing models. So CLI-based tools are being replaced by API-based tools as operational efficiency is needed to scale management of servers, services, and network devices. And lastly, the reliability and the cost effectiveness of the cloud network can make or break cloud business models. So as a result, organizations are looking for more efficient modern network architectures that can be managed, monitored, and deployed in a scalable manner. So emerging operational models like DevOps and NetDevOps are bringing continuous integration and continuous development to data center infrastructure.
Well, so Bill, when we look at the enterprise customer, the shifts that are happening are really astounding, and it's happening quickly. So how can enterprise customers really keep abreast of this kind of paradigm shift in the data center and really adapt themselves to the cloud era?
Yeah, that's a great question. For one thing, it's critical that enterprises do this, right? Because smart businesses are doing it, and to stay competitive, you need to understand what cloud means for you, what this digital transformation means for you, and how you can potentially leverage it to your advantage, right? If you just look at the basics of the infrastructures that support your business and what it means to your business model, first, you have to consider obviously CapEx or how much or how you spend to get the infrastructure. The cloud model changes things considerably. I mentioned earlier, for new projects, you can almost have zero investment in physical infrastructure by leveraging public cloud. And then on an ongoing basis, make a decision. Do you continue, a consumption model on public cloud or build your own infrastructure? I think even more importantly is what it means to both OpEx and how you do your business on an ongoing basis, right? Jeff kind of talked about this DevOps model. If you look at the way, look at the software world where the idea that, software is developed and continually tested, it goes through continuous integration and continuous deployment. That model now is available for the infrastructure and the network using DevOps concepts. And the result is you can do more with less, right? Everyone has demands that say, hey, do more. You don't get more resources to do it. And the way to accomplish this is through DevOps concepts. I think what's even more exciting is the ability to accelerate what you need to get done, the ability to get stuff done faster, and to minimize time to market. Because if you want to leverage these trends in the industry to your business advantage, if you can get stuff done faster than your competition, you're going to come out ahead. So then the question is, well, how do you get started on this journey, right? And I think we recommend you take small steps at first, but you also want to make plans for leveraging your work for future expansion. So if you have a new, like AI pod that you're considering, or perhaps, maybe a smaller, hyper-converged cluster running just a couple of isolated applications, that's a great area to say, hey, I'm going to adopt a cloud native model for my applications and for my deployment, right? Then I'm going to adopt this automation first mindset. Really, you need this automation first mindset and the thought of treating infrastructure as code to make this whole DevOps model work. And then as an organization, you can start to build up the expertise, the skills, and the actual infrastructure and everything around it to support this model and leverage it for future deployments for really your entire application and infrastructure environment.
Well, so, we're talking about, scaling out the data center. And of course, with the advent of 5G and IoT, networking plays a critical role in connecting all this together. So, Jeff, what is NVIDIA's networking solution for data centers?
Right, Shelby. So at NVIDIA, we provide end-to-end software-defined and hardware-accelerated networking solutions for data centers. So as Bill just talked about, in the data centers, networking needs to provide high-performance, low-latency interconnects to unleash the maximum power of compute and storage systems. So it also needs to scale out easily and efficiently to facilitate data center expansion and cloud integration. And it also needs to be open and software-defined to support virtualization, security, and automation. So only with software-defined and hardware-accelerated network infrastructure, the data center can truly achieve cloud-scale efficiency. So NVIDIA meets all these requirements with a complete stack of networking solutions. So in the servers, we provide ConnectX network adapter cards with hardware offloads. So we call them a SmartNICs. And then also with a Bluefield data processing unit, or DPUs, which accelerate software-defined networking, software-defined storage, and software-defined security. In the fabric, we offer open switches and cables and transceivers to connect these devices or servers. So through hardware acceleration and open networking end-to-end, so our solutions make the network infrastructure totally transparent to every workload and delivers predictable services and with real-time visibility and actionable insight. And furthermore, all these capabilities and services can be integrated into data center infrastructures through APIs, libraries, and SDKs. That's the very definition of software-defined.
We've gone over a lot today. And, as we start to wrap up this episode, we always ask our guests where they see technology going in the next year, because they've got their pulse on things. So, Jeff, let me start with you. Where do you see technology going in the next year?
Sure. I wish I had the crystal ball.
Right.
So if I am to pick, I expect that multi-cloud software-defined automation and AI-driven cloud services will become mainstream. So multi-cloud means the cloud of clouds, right? Including on-prem private cloud, edge cloud, and public cloud, where all of these are integrated seamlessly as a single cloud platform, where the locality of data and computing is totally transparent to the user. And then resources are dynamically provisioned and applications run across the cloud controlled by software. So with quality of service, with total security. And automation is a given in the clouds. So as millions of containers deployed, petabytes of data stored, a lot of users service dynamically, the networking is in constant change in both capacity and scale. So by replacing manual network operations, automation is the only way to achieve and deliver services. So configuration will be programmed, simulated, validated by software before the physical network is actually deployed. So everything will be API driven. So we'll see more adoption of continuous integration and continuous development we just talked about. And later in this podcast series, we will talk about NVIDIA Digital Twin, which provide a way to pre-test, validate your deployment before it happens so that you can deploy for production with confidence.
Right.
And then AI-driven cloud services really just mean that we extract insights, with AI and machine learning from the data collected in the data center and deliver services in great accuracy. Obviously, all these highly depend on networking that provide predictable service performance and open, flexible, and scalable, and reliable and secure. So, for the underlying network technology and solutions, I strongly believe next year we will see fast adoption of DPUs, 200, 400 gig high-speed open networks, and container-based virtual networking.
Bill, how about you?
Yeah, and a couple parts to it. The first part is GPUs everywhere. I don't say that just because we're with NVIDIA. I say that because AI is changing the world, right? And organizations are going to need to figure out how to leverage it to, grow their business and how to deploy the infrastructure to support it. So in order to do that, there needs to be the idea of a full stack convergence. This is deploying platforms that support everything. This has the foundational pieces that are, provide the, GPU accelerated software. This is coupling it with well-known enterprise management platforms like, VMware, vSphere, Tanzu for container deployment and orchestration, and doing this in certified systems where this full stack is out of the box, ready to go. It's certified, it's been tested, there's full support for it. So I think we're gonna, because of the growth of AI, and because organizations need to do it quickly and do it in a fully, kind of supported manner, we're going to see the growth of this over the next year. Specifically on the network, I kind of touched on it earlier. Security is becoming a bigger and bigger concern. Obviously, it always has been a concern, and I think in the world that we're going into, the growth and concern is even more so. So there's the idea of zero trust security. This means that, a server or even, a container can't talk to anyone else unless it's explicitly allowed to. Jeff kind of talked about our DPUs, our data processing units. These are central to providing this kind of zero trust security. And we're going to see this really kind of, huge growth in this over the next year. This also ties into the idea that if you look at the network with the DPU and the server, the actual network fabric is becoming simpler. The security stuff, segmentation is now moving to the server, and the actual fabric supporting it in the data center is requiring less features and becoming more simplified. This ties into a very kind of popular open source, open networking project called Sonic. If you look at Microsoft Azure, they're the main backers of Sonic. It's a network operating system that runs on network switches, including NVIDIA Spectrum switches. We expect to see continuing huge growth in open networking and Sonic in particular over the next year. So that's going to be very kind of exciting to see as well.
Well, fantastic stuff. A lot of great insight and a great crystal ball into what's happening in data centers. Well, I surely do appreciate all of your insight. Jeff and Bill, thank you so much for joining me.
Yeah, thanks, Shelby, for having us.
Thanks a lot, Shelby. I enjoyed it a lot.
And thank you, listeners, for tuning in and subscribing to B2B Tech Talk with Ingram Micro. If you have a question or like the episode, please join the discussion on Twitter with the hashtag B2B Tech Talk. Until next time, I'm Shelby Skurhawk.
You've been listening to B2B Tech Talk with Ingram Micro. This episode was sponsored by Ingram Micro's Imagine Next. B2B Tech Talk is a joint production with Sweetfish Media and Ingram Micro. To not miss an episode, subscribe today to your favorite podcast platform.